Okay, so let me just repeat. We're going to be factoring a difference of two squares, which looks like this. You've got two terms, must have a minus in the middle, and these both have to be perfect squares. And then it will factor, you'll take the a and split it both places, and the second term you'll split it both places. 1 plus, 1 minus. It doesn't really matter which goes first, the plus or the minus. You'll get in the habit of doing it one way all the time, but it does not matter. All right, so example B here, 1, 2B. We've got the x squared, and then 81 could be thought of as 9 squared. So I've got the difference of two squares. So I'm going to have two parentheses, one with a plus, one with a minus. Let me see, I've done it both ways here. My x is going to go first, and my 9 is going to go second. So 9 times, positive 9 times a negative 9 is negative 81. Example 3, same thing. Here, the 4s, we got a coefficient here, but the coefficient also must be able to be written as a square. So this is 2 squared x squared, and then minus, and then 1 is 1 squared. So you can see all of these are squares, and I have the difference there. So this is going to factor. I'm going to put my 2x times 2x plus, minus, and then 1 and 1 right there. B, here my 25 is 5 squared, a squared. 9 is 3 squared, b squared. So I have the difference, and then all the pieces are squares. So when I rewrite that in a factored form, I'm going to have 5a times 5a. You see that gives me 25a squared plus minus, and then 3b and 3b. And again, that gives me minus 9b squared right there. C, I have y to the 4th minus 16. And y to the 4th then is going to be y to the 2nd squared minus 4 squared. So when I factor that, it will factor into y to the 2nd in both spots. So that's going to multiply to be y to the 4th. Then I've got a plus and a minus, and then my 4 and 4. So 4 times 4 is 16. So I factored it with a difference of squares. However, you can see that I've got, in these answers, I have some squares. Here's a y squared, and here is a 2 squared. But in this one, I have a plus, so this is not the difference of 2 squares, so this won't factor again. But the second parentheses is the difference of 2 squares, so it will factor again. So when I write this in factored form, I'm going to write another line. I'm going to copy this as is, and then I'm going to factor this one because it factors again. And it's going to be y plus 2, y minus 2. See, y times y is y squared, 2 times 2 is 4, and negative 4. And so that's going to be completely factored. So once you factor it, if you've got squares in your answer, you need to consider, do you still have the difference of squares, and can you factor it again? D, I see these are squares, but here I have a plus. So on this one, I'm going to say that it's prime. I'm going to make a note, can't factor because it's not a difference. So let's write that down right there. It's not a difference. E. So for E, we've got x squared squared minus y to the 3rd squared, power to a power. So when we factor it, again, it's the difference of squares. I'm going to put x squared plus y to the 3rd, then x squared minus y to the 3rd. And here I have a difference, and here's a square, but this is not a square, so I cannot factor that again. And one last one, F. All right, so that looks like quite a mess, doesn't it? And there's a bunch of squares in there, you can kind of tell. However, now let's start talking about the very first thing you typically will do when you start just in general working on factoring is you will look for a GCF. So I'm just going to write it, GCF. Is there one there? And so take a look. So you see I've got M's in both of these, so I can remove an M. And in fact, they are both have a 4. They both have 4 M's, so I'm going to take out an M to the 4th. And then, oh, I noticed that there's N's in both of them too. So there's 2 N's in both of them. So I am going to take out that GCF, M to the 4th, N squared. So dividing, oh, that's going to give me a 1 minus, and then dividing here, 8 minus 4, that's going to give me M to the 4th, and then N to the 12th over N to the 2nd is going to be N to the 5th. That is not technically in standard form, but let's just let's rearrange it then. So we're going to have M squared, N squared times a minus M to the 4th, N to the 5th minus 1. So kind of switch the two so it's in a standard form. That means I'm going to need to take it. Oh, no, we're not going to do this. We're going to, yeah, this is a plus 1 right there. It's a plus 1, so that's a plus 1, and that's going to go there. So I'm going to take out a minus, so M squared, N squared, and then that's going to leave me with M to the 4th, N to the 5th minus 1. And are those the difference of squares? There's a difference. This is a square, but this is not. So I can't factor it anymore, and so this would be my answer right there. And we will stop. Okay, so I'm not going to stop because I noticed something that I did. 12, when I'm canceling this should be a 10. I think I was thinking ahead in my mind. So these should be 10s right here. And then, now I do have squares. So this is going to factor a negative M squared, N squared. This is going to factor here into M to the 2nd, N to the 5th, M to the 2nd, N to the 5th, plus 1 minus 1. And that then is our answer, corrected.